21.4 Day 1 Volume of Spheres Content Standard. Give an informal argument using Cavalier's principle for formula for the volume of a sphere and other solid figures. Language objective. Explain to a partner how to apply the formula for the volume of a sphere. Right, so here is an investigation or explore part to develop the formula for the volume of a sphere. Right, to define the volume of a sphere, compare one of its hemisphere to a cylinder of the same height and radius from which a cone has been removed. And then say that the region of plane that intersect a solid sphere is called a cross section. To show that cross section has the same area at every level, use the Python Theorem to find the relation between R, S, and capital R. Right? So here we can see that they form a right angle, okay, and that's the radius R. Right? So then the Python Theorem say that then R is your hypotenuse. So then it's x squared plus capital R squared equal to the radius squared. Okay. Right. So then here they give us the formula for the volume of a sphere. Okay. So the volume of a sphere with the radius R is given that V equal to 4/3 times pi times the radius cubed. Right? And you can use the formula for the volume of a sphere to solve a problem involving volume and capacity. So let's go to example 1. Right? The figure represents a spherical helium-filled balloon. This tourist attraction allows up to 28 passengers at a time to ride in a gondola suspended underneath the balloon. As it cruises an altitude of 500 feet, how much helium to the nearest 100 gallon does the balloon hold? Round to the nearest 10. So here we're given that 1 gallon is approximately 0.1337 cubic feet. So first, step 1, find the radius of the balloon. Right? So we're given that the diameter is 72 feet. That means that the radius is half of that. So 72 take half, so it gives us 36 feet. So then step 2 to find the volume of the balloon, so be 4/3 pi 36 raised to the third power, or you can change pi to 3.14 and 36 raised to the third power, and from there just use your calculator. Okay, so then this is approximately 195,333.12, and this is in terms of cubic feet. Right, and for number 3, find the capacity of the balloon to the nearest gallon. Right, so then we can say that this is 195,333.12 cubic feet times 0.1337. Let me rewrite this. Times 1 gallon over 0.1337 cubic feet. So then the cubic feet cancel out, and that will give us our gallon. So let me write it here. So they give us 146,098 0.7 gallons. Right. Okay. So let's go on to number 3. So then we gotta try number 3 and 4 on your own. A spherical water tank has a diameter of 27 meters how much water can a tank hold to the nearest liter. Right? So we see that the hint gives us that 1,000 liter is equal to 1 cubic meter. Okay, so now we want to convert this into a liter. So we say that 1,000 liter is over 1 cube, right? So then we convert, this gives us 10,300.77 millimeter times 1,000 liter over 1 meter cube. So then the meter cube, they cancel out. And this is in terms of liter. Okay, so let's go on to our next one. So here it said find the volume of a sphere round to the nearest tenth. So for example 2, you're given that the radius is 3.7. And to the nearest, so take the 6, 7 on to the nearest 10, so we can round this off to 212.7, and this is in inches cubed. I see. Okay, so even if in the calculation you don't include the inches, but when you write the answer, make sure that you include the units. In this case, is in inches. Okay, so let's try number 5. So find the volume of a sphere, leave the answer in terms of pi. Okay, so do not change pi into 3.14. Okay, or you can write this as a fraction. Still the same answers. Let's try number 7. Right, so find each measurement. Give your answer in terms of pi. Okay, so for number 2 is a hemisphere, right? So then it's half, so then you do the volume is 1/2 of 4/3 pi r cubed. And then the 4 and the 2 can cancel out, so this gives 2/3 pi r cubed. And then the diameter is 18, so the radius will be just 9. Okay. Right, so then for number 3 and 4, say that the radius of a sphere with the volume of 36,000 millimeter cube. Right? So here we're giving you guys the volume, you're looking for the radius. Okay, so then for 3 we can say that 4/3 pi r cubed, so change the volume into 36,000 equal to 4/3 pi r cubed. So then to solve for it, we need to do the reciprocal, so time by 3/4 time by 3/4. Right, so this cancelled, or they reduce to 1, so we have pi r cubed. So give us 27,000, and then divide by pi. So let me change this. R cubed, so to solve it, you take the cube root. So that they cancel out. Okay, so then the radius for number 3 is approximately 20.5, and this is in millimeter. Alright, so I'm going to erase this out. Let's try number 4. So let me change it into red. Right? So for number 4, it said Margaret is Thursday after a 5K run for charity. The organizer offered the containers of water shown in the figure. Margaret wants the one with the greatest volume of water. Tell which container Margaret should pick. Alright, so first let's find the volume of a sphere first. So it would be 4/3 pi times the radius 2 to the 3rd power. Okay, so then this is approximately 33.493 inches cubed. Right? Now find the volume of a cylinder. So then would be the area of the base, so pi times the radius squared and times 2. Okay, this is 2512 cubic inches. So when you compare these two, the volume of the sphere is greater, right? Okay, so let's go into the next one. So this is the end of our day 1, 21.4. You have your book set assignment, you have your HRW assignment, and you are also to copy down notes for 21.4 day 2.